So often when we're talking about work and energy, we refer to the principle of conservation of energy. And it basically says that if a particle is moving and there are no external forces other than gravity, so in other words, we have smooth surfaces, there's no friction involved, then the total mechanical energy, in other words, the kinetic energy and the potential energy, will remain constant. In other words, the energy at the start will be exactly the same as the energy at the end. No energy has been put into the system by a force or an engine, like for example, and no energy has been taken out of the system due to friction or something like that. One way maybe of saying that is that the potential energy at the start plus the kinetic energy at the start, PEI plus KEI, is equal to the potential energy at the finish, the final potential energy, plus the final kinetic energy. So let's have a wee example of this. A particle of mass m kilograms is released from rest at a point A on a smooth plane inclined at alpha to the horizontal, where sine alpha is 3/5. Find the velocity acquired by the particle after travelling a distance 6 meters down the plane to point B. Okay, so here's our plane with our particle on it. And it's a mass m kilograms, so it has a weight of mg. We have a normal reaction coming up this way. And this angle in here is alpha. If this is point A here and we get down to point B, in terms of potential energy, what we need to do is work out, well, what is this height here? And again, I'm going to take the bottom of the slope as my value for where the potential energy is equal to 0. So at point A, this mass will have more potential energy than at point B. Now, again, can we work out, well, what that distance is? Well, we're told that it slides 6 meters down that slope, and we're told this angle is alpha. So to find the value h there, we would need to do 6 sine alpha to get h. But we know sine alpha is 3/5, so 6 times 3/5 is equal to h, so h is 18/5, and we'll just leave it like that for the moment. Now, by the principle of conservation of energy, then the initial potential energy plus the initial kinetic energy will equal the final potential energy plus the final kinetic energy. Now the initial potential energy is mgh. So the mass is m, g we're going to put as g, h we now know is 18/5. The initial kinetic energy, a half mv squared, well, we're told that it's released from rest. In other words, its initial velocity was 0, and that means that its initial kinetic energy is also 0. Then let's look at the final potential energy. Well, I've said that this level here of potential energy is where it's equal to 0, so its final potential energy, mgh, is 0. However, it does have a velocity now after having travelled 6 meters down the plane. So it's a half m v squared. So the m's will cancel both sides here. What we're going to get then is that 36g/5 equals v squared. Multiply both sides by 2. And so v equals, we put that into our calculator, v equals 8.4. And again, it's a velocity, so it's meters per second. And we were able to find that because we knew there were no external forces acting on the system, and so the energy at the start equal the energy at the end. And that's what we call the principle of conservation of energy.